Remember when you were a little kid and you have a book bag, maybe 6 years old or 7 years old, and you swing your book bag in a circle? Who knew when you're 6 years old that this problem would come back to haunt you as an adult? But it has, as it turns out. This is a problem with circular motion, and when you're drawing that book bag in a circle, you're pulling it in. And that inward force, to give the name, is called the centripetal force. Centripetal force. A lot of times they'll say centripetal or centripetal because that word is confusing. But according to Newton's third law of motion, for every action there's an equal and opposite reaction. So as you're pulling in, it's pulling your hand out, or your wrist out, or your shoulder out. So these two forces are equal to one another. And actually, a lot of times people will end up with a dislocated shoulder or dislocated wrist by doing this, that the force is too large. Now the formula that we use for force, this goes back now to chapter 5 in the textbook. The force depends on the mass of the object, depends on the velocity squared, it depends on the mass of the object. So just give it, the radius of the object, radius of the circle. Now you can actually do this for yourself. Suppose that the mass of the object is about 2.2 pounds. It's about 1 kilogram. And suppose you're moving at a speed, let's say in a circle, let's say about 3 meters per second. And suppose the radius is from your shoulder all the way down to where the object is, suppose that's 1 meter. And so what you can do is you can calculate 1 times 3 squared is 9 divided by 1. This force would come out to be about 9 newtons for this problem. So this is a problem where it goes beyond our typical experiment in lecture class. You right? Okay. Now here's the apparatus we're going to use for this experiment though. And I have this apparatus somewhere. Now where did I put it though? I just set it out here for a little while ago. Okay, I'm sorry. Oh, I found it.